everybody, this is Silvia from the AIT Austrian Institute of Technology. Batteries play a very important part in our everyday life. Cars, smartphones, tablets, computers, we need them everywhere. And we have high demands. We want them to be smart, efficient, long-lasting, but also environmentally friendly. So that is why today I am checking out our AIT Battery Lab, where our scientists work on the battery of the future. Come, follow me. So, first rule of business, never ever enter a lab without wearing a coat, because it'll protect you and your clothing from chemicals. Hey Marcus.
Hi Sylvia.
How's it going? Yeah, I'm well, always good to see you. So we're here at the AIT Battery Lab and you're heading the battery team. So what is it that you guys are doing here all day?
Well, you're in a chemistry lab right now, so what we do is we actually develop new materials for batteries, for battery solutions, and we're also trying to improve existing ones just to make, the batteries we have last longer, be more efficient, and of course, be more cost effective.
Something that I've always wondered, I recently heard the term battery of the future. What is a future battery and when can we expect that?
Well, there are actually a lot of future batteries out there, so there are various technologies out there. What we're trying to do here is to improve existing lithium-ion batteries, which are currently in the market. So you have one in your pocket, and we have one in our cars if we're driving already an e-car. And of course, they still need improvement. They need to go longer. They obviously need to be cheaper so everybody can afford it. But at the same time, we're also looking into the future beyond lithium. So we're looking at new materials like sodium ion, magnesium ion, just to go beyond what we have right now.
Lithium, why lithium?
Well, lithium is actually a very light metal and it can actually store a lot of energy, so we can get a good amount of energy just out of using lithium metal. But of course, it's not the only material out there, and we're trying at the moment to replace this with other materials.
Okay, so how does what you're doing here is beneficial for people outside?
Well, in various ways. So of course we're trying to be greener in the future, and everybody tries to improve their lives, of course, their quality of life. And e-mobility is one example how we can do that. So what we're trying to do is trying to make the batteries cheaper, more accessible, safer, of course, so you don't have to be afraid of an electric vehicle anymore. And of course you want to drive further with it, so we need to make it last longer as well.
So something that we're all occupied with is green tech, is sustainability, is climate protection. So how are you guys making a contribution to all of that?
So what we're trying to do, of course, is to reduce CO2 and other emissions. And one way in transportation to do that is to go from fuel-based transportation to e-mobility. And e-mobility is, of course, a big topic. And what we need for it, amongst other things, are efficient batteries to bring us from A to B. So at the moment you're used to driving your car and refueling it, and you drive your 400, 500, 600, 700 kilometers or a lot more. And with e-cars you can't really do that at the moment, and that's what we're trying to change.
Mm-hmm. So what happened to me is the other day, so with my job I'm always on the phone, talking. So I depend on a strong battery. And just the other day I forgot my power bank at home, so I had no opportunity of charging the phone in between. So in the end, I almost ran out of battery. So what could I do to avoid that?
Well, it's of course a common problem, and I think one thing is, to see how a battery is being used. So in your phone, for example, you actually need quite a lot of energy to power things like wireless, like Bluetooth and all the likes. So, and your internet, of course, actually draws a lot of power from that one little battery that is in there. So to save it a little bit, you can try to make this process a little bit more efficient. And of course, I don't want to say reduce the time you spend on the phone, but of course, for some people that might also be a good advice.
So Marcus, I've always wondered, what qualifications do you have to have in order to become a battery researcher?
Well, actually, we need a multitude of people, so with a multitude of backgrounds. So we've got chemists, we've got physicists like myself, you've got engineers, we've got, of course, also technicians, electrical engineers. So we really need a lot of disciplines just to really develop a new battery of the future. And that's particularly true for research, but also for the actual industry.
Okay. What we're looking at here are so-called coin cells. And I touch one if I may. I wonder, what is that? Is that a future battery, like one I have in my phone?
Well, it may be, you know, part of your new battery phone. What this is a coin cell. That's where we do the new sort of materials research. It means if we made a new material, we of course need to test it. So we need to see whether the material can do what it's supposed to do and how good it is. And that's always a starting point, and that's the kind of standard you have in the research world. And that, of course, then we need to evaluate whether this material needs to be further developed or if it's promising enough to go on the next step.
Okay. So I suppose you work a lot with the industry outside. What do you do for the industry?
Correct. So actually what we do is we make sure that we always have industry in most of our projects, because firstly we need to make sure that what we develop is actually relevant to them. And it's quite important to also know what the state of the art is. And you get that, of course, from the academic world, but you also get that from the industrial world, because both views are quite important to really deliver the new solutions for the future. And of course, what you've seen here, so this battery is, of course, maybe the new material of the future, but it won't power your car or your phone. So what you need is something that's a little bit larger than this. So what industry actually needs is a scaled-up version of this to make sure it's actually ready for production. And that's what we help with as well, by looking exactly at the processes needed to make a battery in a pouch cell format, for example, a popular format for cars or for phones.
What is a pouch cell?
Well, a pouch cell looks a little bit like this. So actually what you have is here, you have a multitude of layers in there of, you know, electrodes, cathodes and anodes, so-called. And you can actually make that larger and bigger to basically get more energy in there. And that's one of the formats that are used in industry. So something like this, of course, a little bit bigger, is actually used in some of the electric vehicles and may well be used in the phone you're carrying right now.
All right. So at AIT, we are moving in two different worlds. We want to be scientifically excellent, but we also want to be a reliable partner for the industry. How do you, in your everyday work life, combine these two worlds with one another?
Well, bridging that gap between those two worlds is actually quite challenging, but that's exactly what we're here for. So in most of the projects we have, we work with both academia and industry together, and we're trying to bring those two worlds together. And that's basically our task in most of the projects we have. And at the same time, when we go to conferences, exhibitions, we're trying, you know, to draw both of these worlds also to us and get them to talk to each other, because that is actually quite important to bring the new future battery solutions into the market.
I wonder, the term of sustainability is now everywhere. But to me, that sounds quite abstract. So how could you put that in a more concrete context when it comes to your own work?
Well, sustainability means a lot of things. So when we look at the circular economy again, we basically need to think about how do I extract raw materials? Which materials do I choose? So, for example, lithium is at the moment one of the materials we use, and they also contain cobalt, for example. So a lot of our projects here at AIT are also in that part concerned with using alternative materials to lithium and also reducing the cobalt content in the current lithium technologies. So that's the first thing we need to look at. And sustainability also means when we make a battery, we also need to worry about how we make this battery. Do we use a very toxic process for that? Then it's not really sustainable. So we're looking at new production processes, and some projects really are concerned just with that. And if we go even further and we look at, for example, second life applications, so when we use a battery in a car, that battery needs to go somewhere when it's not anymore usable as a car battery. And first of all, that could be a second life application. And what we need for that are diagnostics and methods to actually check whether these batteries are still safe and good to be used. And a lot of our activity is also kind of focused on that part, to make sure second life is an option and where it isn't, to go further then to the recycling process.
Right. You mentioned cars, so e-mobility is another buzzword that is currently all around the place. So how do you work on e-mobility here?
So I would always prefer to say we work on transport solutions, because e-mobility in the car sector, automotive sector, from my point of view, is just a start, and we've seen a lot of solutions now coming into aerospace, marine applications, and of course also larger transport solutions. But of course for everyday use, the car is something that each one of us is using, and heavily, and I think there are the most promising first steps towards an electrified future in the transport sector.
Mm-hmm. You mentioned second life. What do you mean by that?
Well, in the car, it's often the case that a battery gets used for a few years, 5, 6, 7 years, and you just don't get the full range out of it anymore. So you exchange the car, you exchange the battery, but at that point the battery still has a lot of energy in it and can store quite a lot of energy. And we want to use that. We actually want to use that, for example, as a grid storage or a storage system for home, for solar power and so on. So this is a way to really use the full potential of the battery even after it served its life in a car.
Right. So suppose a customer would approach you saying, I need help with my battery. What advice would you give them?
Well, it's often something that depends a lot on the application. So there is not one wonder battery that can serve all purposes. So what we would usually do is we would kind of assess the application that the customer has in mind or that is planning to do and the innovation they want to bring to the market. And we help by first assessing what systems are out there, what are the most appropriate ones. We can test them, of course, and see if they really do what they're supposed to do. And of course, if they really need a completely new approach and a new system, a new battery, then we can start a development project with them to make sure that we get exactly the kind of system that they need.
Customer fit, so to speak.
Right. Purpose made.
So according to your perspective, what is the next big step in the battery industry?
So I think over the next few years we'll see a couple of incremental steps and improvements in current lithium-ion technology. But I think the next big step will be all-solid-state technology. So all-solid-state means we replace the liquid, flammable electrolyte that is in current batteries with a solid one, and that will make them safer and allow us to put more energy in the same kind of space and weight. That will be a very, very big step for future battery applications.
Right.
And beyond that, I think we're really talking the next 15 to 20 years when we're trying to replace lithium ions with other ions, such as magnesium, for example, that will then also have the same challenges. And that's why all-solid-state technology will help us not just with lithium ion, but also with the future generation of ion batteries.
So why is magnesium better than lithium?
Magnesium is one of the potential materials to replace lithium. It has more than one electron that it can store, so it can store more energy per atom. And more importantly, we talked about sustainability. Magnesium is quite abundant, so there's a lot of it in the world. And we can get to it a lot easier than we can get to lithium, for example.
So Marcus, unfortunately our time has come to an end, so I'm gonna leave you now. But I wonder, after I have left, what will be your next projects? What will you be working on next?
At the moment we're busy with some European projects that look into production processes and green production of batteries, and also into smart cells, so diagnostics and state of health estimation, quite important actually for second life and for recycling.
Well, thank you so much for having me. All the best with your endeavors, and I see you soon. Bye-bye.
See you. Bye.